Okay, so let's start looking at the week 7 materials from now. So so far we have finished until week 6. So this is week 7 material. In this week we'll be focusing on design for sustainability. So far we said, okay, how to do an LCA exercise. We went over a little bit of a background about sustainability. We looked at the risk assessment protocols, how to do the risk assessment. We also looked at some basics on toxicity and all that. And the last week we looked at what are the good points of doing an LCA, then what are the good points of a good LCA, like how to make sure you conduct a good LCA exercise. So, and also we looked at the material flow and all that, green material, sustainable material. So with all those concepts now behind us, we as an engineer, this is an engineering course, so as an engineer, our goal is to always design something. Even if you are not an engineer, you will be, when you are working, basically you are working in an organization, you are designing something. So when we say design for sustainability, what does that mean, and what are the things we need to look for? So this week we'll be focusing on that. Like when we say something, okay, let's do some sustainable design. So what we really mean by that, most of it we have already covered. So but what are how we go about it? So we have covered the basics of that, but now how to go about a design incorporating the sustainability factors. What are the things you need to do? What are the tools available out there? So we'll be discussing those aspects in this particular module, in this particular week, and starting with this particular module. So when we say design for sustainability, we'll look at the economics, we'll look at the environmental and social. So and then examples of use of an LCA tool, we'll try to do that. So let's look at the first part of it in this particular module. What is design for sustainability? So we'll try to answer that in next 25 30 minutes this video. When we say design for sustainability, what exactly we mean? So what does that mean? We mean that designing objects that are from renewable sources. Remember we talked about earlier that what is the sustainability means? Sustainability means the use of resources today in such a way so that our future generation can make use of the same resource. They can have the same amount of resource available for them for use. So how that will happen? It can happen if we use a lot of renewable material. If we use renewable sources, we can make that happen possibly in terms of designing objects that are from renewable sources. And then of course any design we have to do it has to fulfill the need, it has to do its function, it has to, otherwise the product is useless. So if you design a product and if it doesn't able to do the function for which it is designed for, there is no point having that product because it's not going to be used. And then we want to design something which is a positive long-term social impact. So it helps socially. It helps in skill development, it helps in upliftment of the people, it creates labor, it creates jobs. So all those things, and some has a positive social impact coming out of that. And whatever is the negative impact which is there, minimize it, and if possible turn them into a positive situation. So as much as possible, any activity will do, there will always be some negative impact. When I say negative impact, even the environmental releases in terms of the water waste or the solid waste, liquid waste or solid waste, they are kind of a negative impact. But then if you can recover the material from these waste stream and make use of those material, that kind of converting that from a negative to positive. So these are some of the concept, like what we should do in terms of the sustainable design, and why it is good, why we start talking about sustainable design for say last decades or so, or maybe almost 15 years. Kind of it started in late 90s, so we can say almost 20 years people are talking about this sustainable design. The thing is that we are today we are living in an ever changing world. The world is changing, our planet is becoming important for generations that will follow. Our planet was important earlier as well, but now with the more population load, more demand for resources, so things are becoming much more complex. How to manage our resources so that our future generation can sustain. We want to make sure our population is going to increase. We have more people coming into this planet by 2050. almost 25% more increase we are expecting in terms of population. We have to feed those people, we have to give shelter to those people, we have to have clothing for those people, we have to have all those recreational activities that they will aspire to have. As the GDP will go up, everybody will try to have those kind of material. So there will be a lot of demand of those materials, so a lot of demand of those resources. So how to we have to look at these things in a very holistic way now, which we have not been doing for almost say for several centuries until now. So especially after the industrial revolution, we need to reduce our carbon waste, and that helps in protecting the planet's ozone layer. Increase in ozone layer will lead us in problem in terms of more UV coming on into the we will have impact on climate change. There will be we do see that in polar regions we are seeing bigger ice melts, and that's kind of creating problem. Polar bear, their habitat is in danger. Many of the islands even nearby us, Maldives, I think I may have told you earlier too, if you want to visit Maldives, we may not have many decades left for that, because what has been predicted that the way the temperature of the world, the global temperature is increasing, Maldives may not be there after after a couple of decades. So same thing for parts of Bangladesh and even some of this coastal areas of many cities around the world, coastal areas of many countries around the world. Sorry. So we have to reduce our carbon emissions. That means we have to from its current status, that we need to change our attitude to what we buy and how we design. We have been getting into the attitude of use and throw kind of concept. More and more products we are producing just for use for few like a few months, sometimes even for a day, or like a use and throw material, and then so we have to kind of think about what really is good and how to, and we have to come up with a better design, and then use materials that are from resources that won't run out and will benefit the planet. So those kind of things we need to do. So when we develop our design ideas or develop your sustainable design ideas, it's basically we are trying to reduce the carbon footprint. And if you remember, this whole exercise of LCA was to calculate carbon footprint and other footprint together, so we call it an environmental footprint. Carbon footprint is, of course, is a big thing, is that. So here we can also generalize, rather than calling it a carbon footprint as it says on this particular bullet, we can say that by developing our design ideas and find ways to reduce the environmental footprint. And how, so we already know how to calculate environmental footprint now. We have had we kind of looked at the LCA exercise. We understand that if we can which we covered in first like up to 4th and 5th weeks module, and so that LCA exercise will help us improve our design in many ways. We can look at how we can look at these different like processes, calculate their environmental footprint. The ones which shows a higher carbon environmental footprint, we can go back and redesign that process and to reduce the environmental footprint. So that will be an iterative exercise, but we can achieve that. So there are some simple ways to develop our design ideas to reduce the product impact, and but any impact, whenever you try to reduce the product impact, you have to calculate that, isn't it? And for calculating, LCA is the tool, which you should already be expert of that by this time, since we have already covered that material. You hear this term again and again and again. Many places you see that reduce, reuse, recycle. So these are in this order because we want to reduce first, reduction of waste, if we can do that, and unfortunately, as our GDP increases, as we get into this more and more mall kind of cultures and online shopping and all that, we have been producing more and more waste. Rather than reducing the amount of waste, we are actually producing more waste. So if if we can somehow reduce the amount of waste, that's we can redesign the project. We can design the project in such a way, so the product in such a way, so that we can reduce the amount of waste that is produced. That will of course benefit the planet immediately. There are many things you can reduce from the materials and components you use to the energy and time it takes to manufacture your product. So these are there, many things that can be done. So that's in terms of reduction, and then of course you have reuse. If you cannot reduce in terms of the waste being produced, let's try to reuse the material. And if cannot be reused within the same system, let's recycle and bring it back into the system, and so that this can be used by something else and for something else. So, and for that we already kind of talked about this concept of life cycle. Understanding of the life cycle is important. So how can you improve its life cycle and make it last longer? Last longer is your durability, and for improvement of life cycle means to reduce its environmental footprint. So how we can do that? We make it strong. So make the product strong, use materials that will last. Many times we don't want actually that way. Many of these, for example, I'll give especially if you think about certain fashion materials these days, people don't like to use certain one material for many times. Just not to offend anyone, but if you think about ladies' shoes, that's just for your for information. I don't want to create any controversy, but just for if you look at even for men's shoes as well, we have a tendency that you don't want to wear the same. Especially for ladies, they want to change their shoes very frequently. So if they don't want to buy something which is very strong, because then it will last for a long time, and they have to wear that for a long period of time. So because it will go out of fashion, and so you basically buy it, use it for a few months, and then throw it away and buy something else. And those products are available in the market. There are products available in the market, very fancy products, and which are cheaper. But they don't last very long. So, and people buy them because they don't want it to last very long, because newer and newer design comes in, newer and newer kind of color combination comes in, and people like to those material. But that has a bigger, if you look at from an environmental footprint, that has a huge environmental footprint. So if you are kind of reusing, if you are throwing materials out at a very at a frequent interval, that it adds up to environmental footprint. So use the material that will last. Choose the best joining method. So you can for the material that you have chosen. And then when you are joining methods you choose, don't try to mix too much of a material. See, the recycling industry today, they are always they have to struggle a lot. When I'm saying why they have to struggle a lot, is if you think about the packaging these days, because of to make things look cool. If you have looked at the next time you are in a supermarket or you are in any market where you are trying to buy some juice or those fizzy drinks, you see there are some newer bottles out there. Some bottles like this is a typical like a reusable bottle, but you will find a juice bottle which will have a wrapper all around it. So there is a wrapper which is all around this bottle. Now that bottle with the wrapper all around it becomes a nightmare for a plastic recycler, because here the plastic recycler person doesn't have any tool to remove that wrapper which is all around the bottle. If you think about a bottle which is like a Kinley or Aquafina, which just have a label on the top, that can be easily removed. But if there is a wrapper which is all through from here all the way to here, all kind of wrapped around, and you see some with some very nice colored combination which looks really very cool, but it becomes a nuisance for recycling, plastic recycling place, because they don't have tools to remove those, and then they becomes a contaminant for other plastics. So they have to take these plastics and separate it, and separation itself requires more energy, more manpower. So they are losing money over there too. So don't try to mix the material. If we can come up with a simple design, is always a better design. But unfortunately, to make things look cool, we mix different types of plastics together, we mix things together, and then it becomes very difficult to separate it, or it takes a lot of time and energy to separate it, and then the economics of recycling doesn't work out very well. So think seriously when you design something, think seriously about what will happen to your product at the end of its life cycle. And this is true for any design, whether you are what kind of engineer you might be, whatever things you design, things at the end of its there will be a service life, and at the end of the service life things will get disposed. So always think from the point of view that when it is disposed, what is going to, how it is going to be managed. So how to reduce its effects on the environment, that's very, very important. So when we talk about all that, any material that we're trying to use, the material has an embodied, there are different types of material out there, and the materials have embodied energy, which term you may have heard about earlier as well. Its embodied energy is the energy that material uses to be made. So when we are trying to make a material, how much energy that goes into that. Lower the embodied energy, better it is, because then it's easy to, it's more it requires, it lets environmental footprint, lets carbon footprint. Glass has a high embodied energy. It uses a lot of energy to be made, where on otherwise wood is a low embedded energy. It doesn't require that much energy to be made. So when using a material, think about where it has come from, how did it get in front of you, how much embodied energy it has, whether we can use some other material which will have lower environmental footprint but gives the same properties, provides a similar function. So those things are important. So we have to look at what materials, properties of the material that you have chosen, do they match the requirement of the product and all that. So with this, all these information, you come up with your design. So you look at, okay, what is the need? So for example, what you want to make out of what is the need, what is the objective of that particular product, what will be the waste that is being produced, what will be the recycle, what will be the life cycle. That's from a sustainable design point of view. And at the same time, you need to look at, okay, what is the function? For example, that's the number one part, isn't it? It has to serve its function. So but you can try to come up with your design concept, and then you write down all the different factors associated with that. Then you make your decision which design comes out to be better. So design need to be developed to reduce their impact. Think about ways in which you can change and develop your design to make it better for the environment. So that's like you have a sheet where you can write down all options. You have option 1, option 2, option 3, and then the one which you kind of feel like has a lower environmental footprint. And the LCA exercise with the database and all those softwares that we talked about can help you to come up with which option. You can compare different options using LCA, and then it kind of gives you some idea about which is better option in terms of its environmental footprint. We already looked at this definition before. Just to kind of revisit this definition, we have been talking about it again and again. So sustainability is the development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So this was with this thing in mind, we have to design what we say design for sustainability. So in terms of its in terms of the industrial revolution, when we have been started producing, this is the figure that you see over here is essentially what we call it a linear economy. So linear economy is when you take extraction of virgin resources, and on top you see the energy, that orange color on top, it shows you the energy, and then arrows, kind of the small triangles coming out, shows the energy input in each of this system. So there is a extraction of virgin resources, that's again energy being imparted to that. Then transportation of raw material, manufacturing process, transportation of goods, consumption, use, transportation of recyclables, recycling, and part of it can go to waste as well. So bottom you see waste all through the process, and energy input all through this process. There could be a circle within it where the consumption, use, and it could be reused, and then recycling can put things back into the chain as well. But for most part, this is what is known as the linear economy. So what today we are talking about is the concept has changed now, and people are talking about circular economy. That's where you hear, if you Google or if you look at any of these environmental magazines or environmental websites these days, there is a concept of circular economy is coming up. So how to like take a material which came from the mining activity, we got the material, and how to keep on reusing it again and again, how to make that happen. So that's the concept of your circular economy. So in terms of the industrial revolution, for last say almost 70 some years, it has released billions of pounds of toxic waste into air, water, and soil every year. We kind of talked about that. Creates material that cause concern for future generation, for their quality of life, produces large amount of waste, and then all these requires lots and lots of regulation to simply regulate the rates of damage of these different points that we talked about earlier. So again, this becomes a concern in terms of its environmental footprint. So in terms of economic, what would be in terms of the model which we want to make it happen? We have economic model of, so there is a part which is a part of the solution which is economically kind of makes sense, part of the solution would be which is socially made sense, and part of the solution which makes environmentally made sense. So in terms of the sustainability, if you think, if you remember from the very beginning, we talked about that there are three pillars of sustainability. There are three. One is economical, the other was social, and then third was economical, social, and environmental. LCA gives us the environmental aspect. In this week, we'll talk about a little bit of economics and social aspect as well. So when you look at these three, they can be in isolation right now. But if we can bring it, and I think it's, if we can bring them together, if we can have a green shift where things can move together, where social, economic, and environmental, they can move together and come up with a solution where we find a condition where these three conditions are made. So that's our sustainable system, where our economic, whatever we want to achieve from the economic angle, social angle, and environmental angle, they kind of meet at one particular point, and that becomes our sustainable solution, and we call it green shift. So sustainable system is a cyclic system, and so you have your raw material, then you have product, then you have consumers, waste being produced, and then for that also we have consumers, and then again the raw material is there. And throughout the system there are some energy which is it's being used, and energy. So if you look at the mother nature, this, as you can, is this particular figure, you can see the mother nature has already kind of they have a system in place. So there are the leaves are made, and the seeds are made, then seeds are ate, and then the waste is being produced, and this waste degrades with the help of these microorganisms or very small organisms, and then the raw material is produced again, and then the new plants will come up. So that's a sustainable system. A cyclic system is already in place. But when we talk about in our in terms of the industrial system, we haven't done that way. When we started looking at our industrial system, several decades back, when this industrial revolution, after that it comes up, we did not pay much attention to social and environmental aspect. We were always looking at the economic aspect, not that much on social and environmental. So gradually we kind of moving into looking at the environmental and social aspect, which is very, very important, and to make things sustainable, to make some things last for a longer period of time. So this development, there was an agenda developed in June 13th of 1992, and from time to time you see this Kyoto Protocol, Davos, and this and that meetings are happening. So representing 90% of the Earth's population was there. The single largest gathering of heads of state of international diplomacy, and then they come up with 6 topic categories in terms of what is sustainability, the quality of life on Earth. So what is the quality of life? Which I think I keep on telling earlier, I think I've said that earlier too. When we talk about GDP numbers are great, but GDP numbers by itself doesn't really tell me much. You may have a very good GDP, but at the same time, if you are having a lot of environmental problems, in my view, in my personal view, that's not really a good progress, because without a healthy workforce, you cannot have a healthy economy for a long time. And I repeat that, without a healthy workforce, we cannot have a healthy economy for a longer period of time. Because if the workforce is unhealthy, because of the environmental implications, say you build lots of factories and all those things, and your lot of productions are going off. First of all, whatever you produce needs to be consumed. So and then even if you find the market for that, and then locally if you have these lots of, as part of your industrial process, you are actually putting a lot of concerned chemicals which creates environmental problem in water, air, and soil, and that will make the people living around those factories sick. And So if those are the laborers, so those are the labors that goes into making the factory profitable. So if you have your manpower sick, manpower are not 100% fit, that leads to the reduction in efficiency of production system, because if the people are sick, they don't work at 100% efficiency, and that will impact the productivity of that industry as well. So and it's all kind of connected. So the quality of life on earth is very important in terms of when we look about the sustainability. Just not having good quality water. Having good quality water is very important. Having as I think I've said that earlier, it looks at, we have to make sure that we have good quality water. Without good water, we cannot really survive for a long time. So for any industry also leads to good quality water. So, and those are very basic essential stuff. The quality of life on earth, efficient use of the earth's material, how to make an efficient use, no much wastage. We don't afford to waste actually. Protection of our global commons. We need to make sure whatever we are doing is it's actually good for our global stuff. And then management of human settlements. We have to make sure that we are not creating a lot of social problem. Management of human settlement, managing the waste, and then economics. So the first part you can see quality of life on earth and management of human settlements, protection of our global commons. These are more in terms of your social aspect. Efficient use of earth's material, chemical and management of waste. These are your mostly from environmental aspect. Sustainable economic growth is what is your economics aspect. So all this has to be there in terms of making it better in terms of more sustainable design, more sustainable environment. So how do we get there from here? When we say here, this kind of gives you the present scenario where we are trying to reduce the environmental impact. We are on this side we have the positive impact, here we have the negative impact, and with all these regulations and other things in place, again this particular figure comes from in Western European countries. From an Indian context, I would rather put this dot somewhere over here, because we are still seeing lots and lots of impacts coming in terms of the large negative impact on the environment, and we have to really start working very hard to take it to reduce the environmental impact and then take it towards the positive impact, where we go from negative to positive, where with respect to time. And how do we get from here? By better design of the products, by better design of the process, by better control of our emissions. So those things will help us to go in that area. So it will just look at a couple of slides and then we'll stop for this particular module. So in traditional engineering, when we say traditional engineering, what we say, we are trying to solve problems that are presented to us the best of our knowledge, with the constraint of approved authorities, with the schedule and financial constraint. So we try to search for methods that maximize function, minimize cost, because that's what mostly we do. We try to maximize the function and minimize the cost to the client, so that it's but now we need to start shift in the engineering mindset. We have to look at maximizing utility while minimizing cost, but at the same time maximize the social benefit while minimizing the ecological impact. So that's where we have to kind of look at that. We have to think about how to. So we have to need a change in our mindset, as I think Einstein said once, that we cannot solve the problem with the same mindset which was there, which created this problem. So the problem that we have today in terms of the environmental issues, in terms of environmental contamination of, like if you think about an Indian context, most of our rivers are contaminated. River Ganga, Jamuna, if you go near Delhi, Ghaziabad, that area, if you go passing through the train, you get such a stench smell. So most of our rivers are contaminated, many of our soils are contaminated. That's why we have the many of the food products we hear about contamination. Air is contaminated, people are getting sick. So all these things was created because of we had a mindset, let's maximize profit, GDP. We are not worrying too much on how to keep our water, air and soil clean. In fact, keeping our water, air and soil clean itself will actually, in my view, will help improve the GDP, because first of all, the people will get less sick, people will be more productive, and at the same time lots of green jobs will be created. So this remediation system, remediating of soil, the groundwater, trying to have the air pollution control systems working, the landfills are better designed, like engineered waste management systems, composting, anaerobic digestion, whatever types of industrial system we want, reuse of the waste material for construction so that housing for all can be achieved, skill development, so training of the people. So all these things will lead to actually lots and lots of jobs being created. And with all these young people coming out from these different universities, we need lots of jobs. So this will actually help in creating lots of jobs and will help in improving the GDP. But at the same time, our industries have to start working in a little bit responsible manner, so that we can achieve these changes in the country. So we'll kind of continue this discussion in the next module, like how we have to move from this traditional engineering to sustainable engineering. So looking forward to seeing you again in the next module. Again, thank you very much, and let's stop here for this module. Thank you.